Good afternoon, everyone. So, in today's class, we will discuss some basic concepts of chemistry. So, in this chapter, mainly they will concentrate on mole concept and stoichiometric calculations, that is limiting reagent, and then percentage of composition or else ideometry, and then concentration terms, that is molarity, normality, right, and mole fraction. So mainly they will concentrate on these areas in this chapter. So first we will see the mole concept and related questions on that one, and we'll discuss even simultaneously we will discuss the PVQ questions also, and then we'll continue with the stoichiometric calculations, and then the mole concept in the solutions, that is molarity, normality, mole fraction, and then some miscellaneous topics like empirical formula, molecular formula, and percentage compositions, right? And then Dalton's law, that is laws of chemical combinations, or any significant figures that we will see at last. The major topics first we will discuss is, that is mole concept, and then stoichiometric calculations. So Dalton's atomic theory, laws of chemical combinations, mole concept, chemical equations and stoichiometry, limiting reagent and excess reagent, percentage yield and purity, reactions in aqueous media and strength of solution, and equivalent concept and law of chemical equivalence. So mainly we will focus on these. So in that one, first we will see one by one here. So according to the slides, if you see Dalton's law, anyway, recent years they are considering even Dalton's law also. So the PYQ, that recent PYQ 2024 PYQ NEET question, if you see, they said that which the following law of chemical combination was explained by the Dalton's theory, and which was not explained by Dalton's theory. The question they asked, which was not explained by Dalton's theory. So in that one they gave law of conservation of mass, law of constant proportion, law of multiple proportion, and law of gaseous volumes. So in these four laws, which chemical combination does not explained by the Dalton's law means, that is law of gaseous volumes, that is given by the Gay-Lussac's law, and he didn't explain that one. So his postulates covers the law of multiple proportion, law of conservation of mass, and law of constant proportion. And anyway, law of multiple proportion was given by the Dalton's only, and if you carefully observe the postulates of Dalton's theory, these law of constant proportion and law of conservation of mass is there in the postulates. So that is why they said, okay, Dalton's theory is explaining all three laws, that is law of conservation of mass, law of constant proportion, law of multiple proportion, right? So in this one, the points as usual you have to remember, which is important for only the in the NEET point of view or JEE point of view. Even the JEE also they are asking this one directly, the points they are asking as it is, the points they are asking, and they are saying that which the following statement is wrong or right according to Dalton's atomic theory. So try to remember those postulates also, Dalton's postulates also. Next one, so laws of chemical combinations. In this one, law of conservation of mass, law of definite proportion, law of multiple proportion, and Gay-Lussac's law of gaseous volumes, and next Avogadro's law. So we'll see one by one in this one. So first, law of conservation of mass. Anyway, you know that the total mass of the reactant should be equal to total mass of the product. That is law of conservation of mass. And law of definite proportion means if you take any compound, if you take, in order to form that compound, the elements, those elements only will combine always in a fixed proportion by mass. Let's take water. So whatever the source of water, whether you are getting the water from anywhere, the water means it is H2O. That means the hydrogen and oxygen, they are combining in the ratio of 1:8. They are combining in the ratio of 1:8. So water, if you take, that is hydrogen and oxygen, there are 2 grams of hydrogen, and the oxygen is 16 grams of oxygen. 16 grams of oxygen. Then if you take this ratio of these two, so it is 1:8. It is 1:8. That means in order to form the water, always they will combine, the hydrogen and oxygen should combine in the ratio of 1:8 by weight. Right? This is not number, this is by weight. Next. So next one is law of multiple proportion. The law of multiple proportion, let's take two elements. Here we'll consider two elements only. Two elements are combining and they are forming two or more than two elements. More than two compounds. Let's take two elements. Let's take nitrogen and oxygen. They are forming the molecules or the compounds. Consider they are forming the more than two. Consider example, we are taking NO. Let's take NO. Let's take N2O. Let's take N2O3. Let's take N2O4 and let's take N2O5. So let's take an examples here. Okay, they gave you an example here. Let's take CO2. They gave CO and CO2. Let's say carbon and oxygen they consider. First you see carbon and oxygen, simple. So carbon and oxygen, they are combining in the ratio of, if you take carbon monoxide CO and carbon dioxide CO2. Now in these two, if you see, carbon mass is fixed. Whereas oxygen mass is, if you take the ratio of the oxygen masses, in carbon monoxide the oxygen mass is 16 grams and in carbon dioxide the oxygen mass is 32 grams. And if you take the oxygen mass ratio, then you are getting 1:2 ratio. That means when two elements are combining and forming more than two compounds, then if you fix mass of one element and then if you take the ratio of mass of other elements, you will get a simple whole number ratio. You can see here, when two elements combine to form two or more compounds, the different mass of one element which combine with fixed mass of other element be a simple ratio. So example, they can take carbon dioxide. So you can see here, carbon dioxide, oxygen is 32 grams and carbon monoxide, oxygen is 16 grams. So 16, carbon monoxide 16, carbon dioxide, oxygen is, carbon mass is fixed here. Here also 12 grams, here also 12 grams. But oxygen masses, if you take, you are getting 16 and 32, that is 1:2. 1:2 carbon monoxide to carbon dioxide. Same like that, if you take N2O, nitrogen oxides, N2O, and you take N2O2, dimer form, N2O2, and next take N2O3. Next N2O4, N2O5 also. Okay, N2O4 and next N2O5. If you take these five compounds, in these five compounds, if you observe, the nitrogen mass is fixed. Everywhere it is 28 grams. And if you take, so mass of one atom is fixed mass of other element that is fixed. And next we have to take the oxygen mass, the mass of one element combined. So mass of oxygen, if you take here, so 16, 32, 48, 64 and 90. So if you take this oxygen's ratio here, you will get 1:2, 2:3, 4:5. A simple ratio you will get. So that is law of multiple proportion. This was is there in the Dalton's law, Dalton's postulates only, within the postulates. Now Gay-Lussac's law of gaseous volumes. So Gay-Lussac's law of gaseous volumes means when gases combine and are produced in a chemical reaction, they do so in a simple ratio by volume, provided all the gases are the same temperature and pressure. So it means these gases, if you see this one, right, if you see this law, the conditions is temperature and pressure should be constant. And if you take any, here you can say the H2O, let's take all of these gases here. That means here the ratio, if you take here, this is one volume, this is one volume, this is half volume, this is half volume, and this is one volume. That means one volume of H2 is reacting with half volume of O2 and you are getting one volume of H2O. Or else you take HCl also. Let's take H2 and plus Cl2 and that gives HCl. That is, so this is okay, let's take 2. This is one volume of H2 and one volume of Cl2 and you are getting two volumes of HCl. Right? This is applicable for only gases. So we should mention all these are gases only. All these are gases only. Next. And Avogadro's law, equal volumes of all gases contains equal number of molecules. That is, the volume is directly proportional to number of moles, provided what is constant here? Pressure is constant and temperature is constant. These two are again, pressure and temperature should be constant. Then only the volume is directly proportional to number of moles. So volume increases means number of moles increases, volume increases, number of moles also increases. Volume decreases, number of moles also decreases. So equal volumes of all gases under similar conditions of temperature and pressure, equal number of molecules. They contain equal number of molecules. So volume is directly proportional to number of moles, provided pressure and temperature is constant. Next, mole concept. So mole concept, say actually we are dealing with the atoms and molecules. They are very, very small. We can't see them and we can't weigh them. So then in that case, but all the chemical reactions are taking place. So we have to say some mass of the reactants is going to react and some mass of the product is going to form. Then how much reactants are going to react? We should have, suppose let's take, you want to prepare some compound. You want to prepare some compound and so much quantity of compound you want to prepare. Then what reactants you have to take, in how much quantity you have to take, if you have an idea, then only you can produce, okay, this much amount of product you can produce. So for that purpose, say atoms and molecules we cannot see, but we have to say the masses. So for that purpose, they introduce the smallest unit of mass, that is AMU, atomic mass unit. It's a relative mass concept. So what is the atomic mass unit? Means one mass of one atom. Okay, what is AMU? AMU is nothing but 1/12th mass of 1/12th mass of carbon-12 atom. This is AMU. So one AMU is equal to 1/12th mass of a carbon-12 atom. Next, so by using this one, they gave the masses of all other elements. That means let's take I'm taking so oxygen. Oxygen atom mass is 16 AMU. So what is its meaning? 16 AMU means it is 16 times heavier than 1/12th mass of carbon-12 atom. So there is only formula they gave. Relative atomic mass is equal to mass of one atom of an element by 1/12th mass of one atom of carbon-12 isotope. So here, so let's take anything we are saying with is a relative masses. So let's take your mass is 10 grams. So let's take 1 gram. Your mass is considered 1 gram. My mass is 10 grams. So I am 10 times heavier than you. So consider your mass is 1 gram and my mass is 60 grams. So then that means I am 60 times heavier than you. So like that, relative atomic masses they gave by giving the AMU. So one AMU is equal to 1/12th mass of carbon-12 atom. And suppose if any other atom, if you are saying its weight is 20 AMU, then it meaning is it is 20 times heavier than 1/12th mass of carbon-12 atom. It's a relative mass, right? Next, and what you want to find out molecular mass. If you want to find molecular mass, then what you have to do? You have to add the mass of all the atoms. So let's take glucose you are taking. Glucose formula is C6H12O6. So in that one 6 carbon atoms are there, 12 hydrogen atoms are there and 6 oxygen atoms are there. So if you want glucose molecular weight, then you have to add 6 carbons atomic weight, 12 hydrogens atomic weight and 6 oxygens atomic weight. So total atoms weight if you add, then you will get the weight of glucose. And don't confuse here, children used to confuse, that is here it is the mass and weight. In the chemistry both are same. So we are not differentiating here the mass and the weight here. That is the difference majorly you will see in the physics. So with gravity, without gravity. Here we are neglecting the gravity here. So with gravity, without gravity here, we are not considering. So both are same here. Mass, that is amount of substance, and weight, amount of substance in the presence of in the influence of gravity, both we are considering same. So mass and weight in the chemistry will be same. Next. So the percentage composition is simple one. So if you are finding the total weight of the compound, in that one let's consider glucose only. So glucose, its molecular weight you will get 180 AMU, 180 AMU. So in that one, now I want how much percentage of carbon is present. How much percentage of carbon is present in the glucose? Then the percentage of carbon is equal to weight of carbon in that compound, in the glucose, by weight of glucose into 100. That means now weight of carbon, that is 6 carbons are there, each one is 12, right? And 72, its weight is 72. So 72 by 180 into 100. Then you will get the percentage of carbon which is present in the glucose. Okay. So next one. If you see some questions here, so an element X is having following isotope composition, that is X200, X199 and X202, the weighted average. Anyway, here I am not going to do this one. This is the average atomic mass. Average atomic mass, that is equal to, that is weight of isotope. Consider isotope, there are 3 isotopes now. So isotope 1, weight of isotope 1 into its percentage of abundance. Its percentage of abundance plus again weight of isotope 2 into its percentage of abundance by 100. So okay, there are 3 isotopes, then you add one more, weight of isotope 3 into its percentage of abundance. So like that, how many isotopes are there? You can add all those isotopes and divide it by 100. Then you are going to get average atomic mass. So why we are finding all these things? Now let's take here. If you take the chlorine atomic mass is 35.5. But if you remember the atomic mass, A is equal to number of protons plus number of neutrons. But 35.5 means there is no half neutron, half proton. It actually is an average atomic mass. That means chlorine will exist as a isotopes, that is same atomic number but different mass numbers. So chlorine 17, but it is existing as a chlorine 17 and 37 and chlorine 17 and 35. So one is 37, 35, one is existing as 75%, one is existing as 25%. Now which one we have to take the mass to do calculations? So what they did, so they gave the average, you take the average of these two along with the multiplier with their percentage of abundance, and then you take whatever the value you will get. So let's take 37. So 37 is 25%. So 37 into 25 plus 35 is 25%. So 35 into 25 by 100. So by doing that one, how much mass you are going to get, how much weight you are going to get, that is the weight of chlorine will take. Because we can't take 37, we can't take 35 completely, because this is 35 is 75%, 37 is 25%. That is why we will take both, and then we will find the average atomic mass, and we will take that is the mass of chlorine. Next. Now this question is good. A crystalline salt Na2SO4.XH2O on heating loses 56% of its weight. The formula of the crystalline salt, right? So means 56% of its weight on heating. That means 56% of weight of that compound is containing water. 56% of the weight of that compound contains water. Now what you have to find? You have to find which is having the 56% of weight. Means in this compound, we according to question now 56% it is lost, means on heating. That means the water is going out. That means 56% of the weight of that compound is nothing but water only. So now you have to calculate in these four where the water is 56% of its weight. 56% of its weight, that is weight of water by total weight of the compound, and into 100. If you get, then you will get this one answer, Na2SO4 dot 10H2O. Next. So mole concept. See, okay, we are dealing with the atoms, we are dealing with the molecules, fine, but they are very small, even we can't see with our naked eye. Then how to deal them? Let's say I am taking a carbon powder. That carbon powder I am taking, I am weighing and I am saying it's 12 grams of carbon powder I weighed. Then the question is in this one, the 12 grams of carbon powder contains how many atoms? I ask the question. Then what you will say? You can't count that one. Then the question comes here, then the topic comes, that is mole concept, because he did that one. So he said that if you take the mass of any element, if it is equal to its, if you take any element, if its mass is equal to its gram atomic mass, now here grams came, or else we'll say here the weight and the number of particles we are going to, we are linking these two. 6.023 into 10 power 23 atoms of any substance, if you weigh, of any element if you weigh, then you are going to get its atomic weight in grams. Or else, if you weigh and you are getting the atomic, you are taking the weight of any element, its atomic mass, gram atomic mass, it contains 6.023 into 10 power 23 atoms. Let's take carbon only. Now carbon you are taking. So carbon you are taking, when you are taking the carbon, and when you are taking the carbon is, you are taking 12 grams. Then the 12 grams contains how many carbon atoms? Or else, in another way we can say, how many carbon atoms weight is equal to 12 grams? Right? So that's why 12 grams is gram atomic mass of carbon that contains 6.023 into 10 power 23 carbon atoms. Or else we can say vice versa, 6.023 into 10 power 23 carbon atoms weight is 12 grams. So I am mentioning here grams, not the AMU. Then what is the meaning of 12U? A 12 AMU means that is one single carbon atom. One single carbon atom weight is 12 AMU or 12U. Then what is 12 grams? That is 6.023 into 10 power 23 carbon atoms weight is 12 grams. The 6.023 into 10 power 23 value is called as Avogadro number. So we can also say Avogadro number of atoms weight is equal to gram atomic weight. Avogadro number of molecules weight is equal to gram molecular weight. Gram molecular weight. Fine, ma'am. Next. Now here, in order to do some calculations here, I will do some formula here. So they will give number of molecules. Number of molecules is equal to number of moles. N is number of moles into Na. Next, number of atoms. Number of atoms is equal to number of moles into Na into number of atoms in one number of atoms in one molecule. Number of atoms in one molecule, or else if they give ion, then you take ion, they take ion. And we know that one number of atoms present in a molecule or in a compound is called as atomicity. So we can also take atomicity also. Atomicity. Next, number of electrons. We'll ask this question also, number of electrons. Number of electrons is nothing but number of moles into Na into number of electrons in one atom, if it is atom is given, or else one molecule if molecule is given, or else one ion if ion is given. Same like that, even the protons are also given, even the neutrons are also given. Then you can also take the, instead of electrons, you can take the number of protons in one atom or one molecule or one ion, or else neutrons also in one atom, in one molecule or one ion. Next, if you want to find out the, now we know that 1 mole of any gas, 1 mole of any gas will occupy 22.4 liters volume or else 22,400 ml volume at STP, that is standard temperature and pressure, right? So how to find the volume occupied by any gas? Volume occupied by any gas, number of moles is equal to volume occupied by any gas in liters by 22.4 liters. That means we can take volume of any gas. The volume occupied by any gas is equal to number of moles into 22.4 liters if you want in liters. And if you want in ml, then we can take n into 22,400 ml. 22,400 ml. Right? So this is in terms of ml if you want. This is in terms of volume if you liters if you want. That is, you have to find the volume in terms of liters, volume in terms of ml. Now everything is interrelated here. Number of moles interrelated, number of particles interrelated, number of particles, number of molecules, number of atoms, volume, right? Number of moles, everything is interrelated here. Means if you find one thing, you can find remaining all the things. The question, the 2026 they gave, that is in 2026 the question they gave, that is 5.4 grams of urea. In 5.4 grams of urea, how many hydrogen atoms are present? In 5.4 grams of urea, how many hydrogen atoms are present? Simple question. So in the question only they gave, this is the leaked one, this is the cancelled one. So in 2026 only leaked one. So to 5.4 grams of urea. Urea, we know that formula. The formula you should have an idea. NH2CONH2. NH2CONH2. That means here if you take one urea molecule, it is having 4 hydrogen atoms. 4 H atoms are present in one molecule of urea. 4 hydrogen atoms are present in one molecule of urea. So if you see the urea weight is 60 grams, that is they gave in the question only. 60 grams of urea, this is same. 60 grams, we are mentioning the grams means it is moles only. That is 1 mole. That means 60 grams, the weight. So what you have to find here, this is the weight, molecular weight of urea. So first, what is the formula I gave? If you want to do formula, you can use a formula. If you want to do concept wise, you can do concept wise, no issue in this one. So if you take the formula, what I gave, number of atoms is equal to number of moles into Avogadro number into number of atoms in single molecule. Number of atoms in single molecule. In a single molecule, this is the formula we will use. So here number of moles is equal to weight by gram molecular weight. If it is molecule, if it is atom, atomic weight. So N is equal to weight, they gave 5.4 grams and gram molecular weight is 60 grams. Don't divide in now only. You will substitute there directly. So we can take, that is N into, okay, sorry. So now the N value we got here, that is 5.4 by 60. And into Avogadro number is, we are taking 6 into 10 power 23 instead of 6.023 into 10 power 23. I am taking 6 round figure for easy calculation. And into number of atoms in a single molecule. Number of, here we are not finding all the atoms, we are finding only hydrogen atoms. So you have to take only hydrogen atoms. So if you take hydrogen atoms, there are 4 hydrogen atoms. So multiply with 4. So this value, if you multiply, you are going to get around 2.16 into 10 power 23. 23 H atoms are present. This is, we are finding only H atoms. Simple question. Next one. Next, one more question in this one. Okay. Next, after this, we will go for the 2025 question. 2025, they gave some masses of the compounds, and they asked which is having more number of atoms. which is having more number of atoms, or which are having equal number of atoms, right? So again same thing, equal number of atoms he asked. So given weight by its gram molecular weight, so you will get number of moles into Avogadro number. No need to multiply Avogadro number. He is asking comparison only. Comparison means no need to multiply. Take that Na is like that only. Then you have to find out number of atoms in all the given weights of the compounds, in all the given options. Then you are going to get, in which options you will get equal number, that is they contains equal number of atoms. Simple question that is also, but little bit we have to see for all the options. It will take some time, but you will get. Simple question. Next one, stoichiometric calculations. So stoichiometric calculations means, see, first of all, what do you mean by stoichiometry and what is the use of this one? So in the stoichiometric calculations, see how much weight of reactant you took and how much weight of the product is formed, or how much weight of reactant you took and how much volume of the gas is released, or else how much weight or how much weight of the compound you took, how many moles of the product is formed. So just now we said everything is interrelated, number of moles and the number of particles and the volume, everything is interrelated. Even the energy is also interrelated. So these many moles, if you take, how much energy is released? So for these many moles, this much energy is released. So these many moles now I took, then how much amount of energy is released? So that is also it's interrelated here. So in the stoichiometric calculations, we will see, now we will see here how much volume of substance, how much weight of substance you took, how many number of moles of substance you took, so that accordingly how many moles or how much volume or how many grams of the product is formed. All those calculations, that is mole weight, mole volume, mole, or you can say weight volume, weight moles, everything will interrelated here, right? So those things, we'll start with an example. So let's take an example. We'll start a simple example, that is water formation, H2 and plus O2, and that gives H2O. Now in this one, H2 plus O2, that gives H2O. Always, whenever you are doing these stoichiometric calculations, always you have to take a balanced chemical equation. That means this is now balanced. Always you have to take a balanced chemical equation. A simple chemical equation is, if you take, you will end up with a wrong answer. So you have to take always balanced chemical equation to solve the stoichiometric calculations. So in this one, H2 plus half O, that is H2O. The question they gave here, when (16 grams of oxygen), then the question is how many grams of H2O is formed. So here we are relating weight and weight. So the reactants we are taking the weight, and the product we are saying in terms of weight only. So weight and weight. So weight, if you take here, how many grams of H2 and how many grams of O2 and how many grams of H2O. Whenever the question, after seeing the question, what you have to do? First, you have to write a balanced chemical equation. Then according to the balanced chemical equation, what are the values you have to write? That means they are asking in terms of weight, then write the weights here according to balanced chemical equation. That means this is 2 grams and this is 16 grams and you are going to get 18 grams. This is according to the balanced chemical equation. So first you have to write the weights according to the balanced chemical equation. Then you write the given weight. This is 0.1 gram and this is, they give 16 grams only, and this is they are asking how many grams of water is formed. This is simple. Okay, let's take here, instead of 0.1 you take 1 gram only. Instead of 0.1 you take 1 gram only. It is easy to understand. So let's take here 1 gram only. So 1 gram of hydrogen is reacting with 16 grams of oxygen. Then how many grams of water is formed? You can see here, in this one, 2 grams of H2 is reacting with 16 grams of O2 and forming 18 grams of H2. Then obviously, if it is 2 grams, then it is reacting with, if it is 2 grams, then it is reacting with 16 grams. If it is 1 gram, obviously it will react with only 8 grams, not the 16 grams. How you can say that one means by seeing the balanced chemical equation only I am saying that one. So here 2 grams is reacting with 16 grams means 1 gram will react with only 8 grams, not with 16 grams. So how much is required? 8 grams is only required here, but how many grams is given? 16 grams is given. That means whatever the quantity we want, they gave more than that. That means now this is excess reagent. This is now excess reagent. And this is limiting reagent. Now the question comes, what is limiting reagent and what is excess reagent? So excess reagent, name itself excess. That means which is present extra in the reaction. Right? And which is present in the less quantity. కావాల్సిన తక్కువ ఉంది. Whichever is in less quantity, that is considered as limiting reagent. That is considered as limiting reagent. Right? Then here, if you see, so 2 grams will react with 16 grams, then 1 gram is reacting with only 8 grams, not 16 grams. Not 16 grams. So why it is not reacting means, see, according to the balanced chemical equation only, to react with 2 grams, 16 grams is required. To react with 1 gram, only 8 grams is required. But 16 grams is given. That means it is extra is given. That means it is excess reagent. And limiting reagent is H2. So H now, whichever is the limiting reagent, that one will decide the amount of product formation. That one will decide the amount of product formation, not the excess reagent. Because excess reagent will remain like that only, whatever the extra quantity. So here 1 gram will react with only 8 grams, not 16 grams. So then the how many grams of H2O is formed means it is 9 grams. 9 grams. So your law of conservation of mass is not applicable because 1 gram 16 you have to get 17 grams, but you had 9 grams. Yeah, but clearly if you observe 16 grams, in the 16 grams is not reacting. 16 grams is not reacting, only 8 grams is reacting. So that is why 1 plus 8, it's 9. 16 grams is not reacting. How much reactants you are going to take? Those many reactants will react. That much quantity, complete quantity will react means that depends upon the stoichiometric ratios. Actually, see, you can eat up to 1 packet of one complete biryani. But I gave 2 packets of biryani. You can't eat. How much ever hungry, you can't eat that 2 because your capacity is only 1. So you can't eat the second one. If you start also, you can't eat that one. Same thing here also. So if it is there, that's why you gave extra. But it's not like that. Another one is in less quantity only. Now the 1 gram of hydrogen can react with only 8 grams of oxygen. It's not 16 grams of oxygen. Then what remaining extra means? It will be like that only. It will be left unreacted. The question tomorrow you will get. Yeah, now also. This is in 2024 or 2023. They gave the question. Yeah, we'll discuss that one also. 2024 PYQ, it is there, right? But they related with the molarity. So and so compounds reacted, and they asked the question, how much substance of that reactant is left unreacted? That is by using limiting reagent. So you can take number of moles here. You can take the mass, in whichever quantity they are asking. Whether they are asking in the number of moles, then you take number of moles. Whether they are asking in terms of weight, then you take weight. And by the way, law of conservation of mass is not applicable to the nuclear reactions. And law of conservation is not applicable for the gaseous reactions. Gaseous one. Let's take here one example here. N2 plus 3H2, that gives 2NH3. This is the balanced chemical equation for the preparation of ammonia. So here if you take, all are gases only. This is gas, this is also gas, this is also gas. Now apply Gay-Lussac's law of gases volumes. He said that is, this is one volume, this is one volume, this is three volumes, and this is two volumes. Here what is in implication here? Okay, ratios if you take you will get, but if you see the reaction here, one volume of N2 is reacted with 3 volumes of H2 and you are getting 2 volumes of N2, 2 volumes of NH3, right? So 1 plus 3 it is 4, you are not getting 4, you are getting only 2, then where is remaining 2? Remaining 2, that means volume is decreased once the reactant's volume is more and the product's volume is less. That means when the reactants reacts and forms the products, the volume contraction, volume decreased, means contraction happened, not the here if it is the expansion is happened then the volume increases, the contraction is happened the volume decreases. Let's take here one more example, PCl5 that gives PCl3 and plus Cl2. Here this is one volume and this is also one volume and this is also one volume. That means one volume of PCl5 decomposed and you are going to get 2 volumes of products, that is one volume of PCl3, one volume of Cl2. Now if you see here, one volume, now product side you are getting 2 volumes, but reactant side you are getting 1 volume. So that means volume is increasing means expansion is taking place. All these things you will get in ideometry. So means the law of conservation is not applicable for the volumes because volume may undergo contraction, volume may undergo expansion. Law of conservation of mass is there, but law of conservation of volume is not there. Law of conservation of mass is there, but law of conservation of volume is not there. Right? So, these are pure examples. Here, contraction takes place. That is why the volume decreased after the reaction. Here expansion is happened. That is why the volume is increased after the reaction. That is after decomposition. So, I hope you understood what is this limiting reagent, what is excess reagent. And remember, always the limiting reagent only decide the amount of product formation. Limiting reagent which is present in the less quantity or which is completely consumed in a chemical reaction, or the reactant which decides the amount of product formation. Any definition we can say, right? So limiting reagent only will decide the amount of product formation, not the excess reagent. So now you want to find out how much amount of product is formed, you have to take only limiting reagent, not the excess reagent. Especially these reactions you will consider in the combustion reactions. If it is a complete combustion reactions, any hydrocarbon is reacted with in the presence of excess amount of oxygen. There itself they will mentioning excess amount. They don't mention also, if it is a complete combustion they are saying. Then the complete combustion they are saying means always you have to consider the oxygen is excess reagent there. No need to mention this is limiting, this is excess. If they are saying it is a complete combustion, that means their O2 is excess quantity. No need to mention because we know that complete combustion will take place in the presence of excess amount of oxygen. Right now, next. So it's very, very important. So excess amounts are limiting reagent, excess reagent, and then the volumes. So this is NEET 2020 question, which the following has maximum number of atoms. So maximum number of atoms means, and now as I said, number of atoms is equal to number of moles into Avogadro number into number of atoms in a molecule, in one molecule, or in one compound, or in one ion. So if you do, you will get this answer. Simple one only. Anyway, they gave your atoms and only one is given molecule. One ml of water contains 20 drops of 20 drops. 1 ml of water contains 20 drops. The number of molecules in a drop of water is, right? So 1 ml. Here I think you should know the density. Density you should know. 1 ml of water contains 20 drops. So in 1 ml contains 20 drops. So in the 20 drops, how much its weight? The 20 drops, how much its weight you have to consider. So if you see here, the volume of water is 1 ml and 1 ml of water contains 20 drops. The 20 drops of water weight is 1 gram. Consider it is 1 ml considers 1 gram. That because the density of water will take 1 ml per centimeter cube, right? So density, mass by volume, no, sorry, density is equal to mass by volume. So let's take density of water is 1 gram per ml. We'll take 1 gram per ml, right? So density, if you take 1 gram per ml, then you are going to get density 1, then volume is given 1. So mass also we are getting 1 gram only you are going to get. So mass is equal to 1 gram. So in 1 gram there are 20 drops are there. So 20 drops weight is 1 gram. So 1 drop weight is how much? So 1 drop weight is how much? That is 0.05 grams. 1 drop weight. Because we want how many molecules are the number of molecules in drop of water. 1 drop we want to find out. So you can find number of moles. Again formula, number of molecules is equal to number of moles into Na. So you find number of moles of 1 drop. In 1 drop, first of all 1 drop weight is 0.05 grams, and then the mole of water, how many moles of water present in that one drop? That is 1 drop, the number of moles is 0.05 grams. 0.05 by 18 grams, you will get number of moles here. This is number of moles. Then they are asking number of molecules. They are asking number of molecules. Number of molecules is equal to number of moles into number of molecules is equal to number of moles into Avogadro number. Then you will get the answer. So in the year, the 1 ml we are considering as a 1 gram because the water density is 1 gram per ml. So you have to take 1 ml as 1 gram, and then in the 1 gram there are 20 drops are there. So 1 drop the weight is how much you have to find out. 20 drops weight is 1 gram, then 1 drop weight is how much? In that 1 drop weight, it is equal to that weight. If you find that is equal to how many number of moles, and once you find the how many number of moles, then you can find the how many molecules are present. Okay, volume of gas at NTP is 1.12 into 10 power minus 7. The number of molecules in it. Okay, we know that 1 mole of any gas will occupy 22.4 liters. That means, see, this is in ml is given. 1.12 into 10 to the power of minus 7 ml is given. So in this ml, this is at NTP. So at NTP, so you can see the volume of NTP. This is 1.12 into 10 to the power of minus 7. 1 centimeter cube is equal to 1 ml. You should know that one. So at NTP, that is 22,400 ml. 1 mole of any gas will occupy 22.4 liters or 22,400 ml. That is 1 mole, that is 6.022 into 10 power 23. Now here they gave volume. They are asking number of molecules. They are asking number of molecules. You can find easily. Next, empirical formula, molecular formula, nothing is there here. Molecular formula is equal to, so empirical formula, molecular formula, if you remember, first what are the percentages will convert into grams, and then we'll divide with the atomic masses. Then whichever will get the least value, we'll divide that least value. We'll take all the values and we'll divide with that least value. Then you will get the empirical formula. After dividing also you are getting a still fractions. Then we'll multiply with any single number. We'll multiply with any number, right? We'll multiply with any number. After multiplying with any number, then we'll get the whole number. The fractions we should not get. So if once you remove that fractions, then whatever the values you will get, that is will take as the empirical formula. Right? So this is not that much important, empirical formula. Already we discussed this one. Limiting reagent, excess reagent is also over. Right? We have to solve few questions on that one. Percentage of yield and purity, and this is important here. Again, percentage of yield and purity. So consider CaCO3. So question is PYQ question, exact values, didn't remember. Let's take rough values you take. We are heating On heating 10 grams of CaCO3, how much volume of CO2 is liberated, provided that CaCO3 is only 90% pure. 90% pure. So once again the question, 10 grams of CaCO3, on heating 10 grams of CaCO3, how much volume of CO2 is liberated? Given that the CaCO3 is only 90% pure, not the 100% pure, right? So generally, if it is 100% pure, then 100 grams you are going to get 1 mole, that is 22.4 liters, the volume occupied by that gas. If it is 10 grams, then you are going to get, it is 0.1 mole, then you will take 2.24 liters. When if the 10 grams is complete pure, but I said this 10 grams is not complete pure, I said 90% of the 10 grams is pure. Now you have to find out what is the 90% of this 10 grams. What is the 90% of the 10 grams? What is the 90% of the 10 grams? So 90% of this 10 grams, if you find out, then it is nothing but 9 grams only. So for 9 grams, so here now we should not consider this one because that is for only 100% pure. Now it is not 100% pure. They said it is only 90% is pure. 90% is pure. So 90% pure, then 9 grams, it is how many moles or how much volume? So for 100 grams, it is 22.4 liters. Then for 9 grams, it is how many liters? Volume, cross multiplication. So in this type of questions, they are giving that this is only that much purity. Complete compound, whatever the weight is given is not purity. So then we have to take only how much okay, you know already the solute, solvent, right? Solutions, weight by weight. Now in this one, mass percentage, mass by volume percentage, volume percentage, molality, and I will say normality also, and I will use one more mole fraction. Now in this one, normality is number of gram equivalents by volume in liter, and mole fraction is equal to number of moles of one component to the total number of moles. Out of these concentration terms, so wherever the volume comes, that will be affected by temperature, that is depends on temperature. Wherever only weight comes, that is independent of temperature. That means now I am writing independent, I am marking weight by weight percentage or mass percentage, and next molality, and next mole fraction. Now these three are independent of temperature because they are having only weight, and whereas remaining all will depends on temperature. The best method to express concentration is normality, because in the normality we are taking the gram equivalents. That is the best one. Right. So hope you remember all these formulas. If you remember, it's better. So in this one, 99% you will get direct formula based only. So weight by weight, weight by volume by volume. From that one, the questions are very rare. Strength of solution is equal to, that is the number of moles, strength of solution, the weight of compound in grams, the weight of substance in the grams, by volume of solution in liter. That is strength of solution. And molarity will get number of moles of solute by volume in liter, right? And here direct formulas I am writing only here. Weight by volume percentage into 10 by gram molecular weight of solute. Next, molarity is equal to weight by weight percentage into 10 into density by gram molecular weight. And this is 1 plus 1 offer, means even normality also same formulas. but normality instead of gram molecular weight will take gram equivalent weight. So if you take here normality is equal to number of gram equivalents by volume in liter, or else normality is also weight by volume percentage into 10 by gram equivalent weight, because number of gram equivalents is equal to gram molecular weight by gram equivalent weight. Then what is gram equivalent weight? Gram equivalent weight is equal to gram molecular weight by n factor or valency factor. N factor or valency factor. So now normality is equal to weight by weight percentage into 10 into density by gram equivalent weight. So same formulas you can see, if we compare these two, same formulas, but instead of gram molecular weight, their gram equivalent weight came. Next if you see here, dilution. On dilution, number of moles of solute is constant. Number of moles of solute is constant. So we can find M into V is equal to constant. Here V is in liter. So we can write M1 V1 is equal to M2 V2. Means before dilution and after dilution. There are two solutions. There is one solution which is having molarity some x value and volume is some x volume. Then what I did, I added some extra amount of water. Then the volume became y value. Then what is the molarity of the solution after adding water? Then we can use this formula. We are adding water, that means we are adding solvent, not the solute. That's why the number of moles of solute will be constant. Suppose there are two solutions are there, the two solutions are mixed. Solution 1, it is molarity is M1, its volume is V1. Solution 2, its molarity is M2 and volume is V2. Now both are mixed. Then the resultant solution molarity is equal to M1 V1 plus M2 V2 by V1 plus V2. V1 plus V2. Right? Now the question is, along with that, after mixing both, along with some extra amount of water is added, then you add that extra amount of water is here. X is equal to extra amount of water added, extra volume of water added. That means after adding the two solutions, again some extra amount of water is added. Then you can take that formula. Next, if you come to the normality, so normality we are saying in terms of gram equivalents, number of gram equivalents, that is equal to normality into volume in liter. So again on dilution, the number of gram equivalents of solute is constant. All the neutralization reactions and all precipitation reactions, all redox reactions will take place in terms of number of gram equivalents. In terms of gram equivalents only. That's why this is the best method to express concentration. So if you take this one, so for a neutralization reaction, number of gram equivalents is equal. Now normality into volume, that is number of gram equivalents. This is nothing but number of gram equivalents. That is only we are writing as GEN. So GEN of acid is equal to GEN of base. Then only it is a complete neutralization reaction. So you can take here, you can compare all these things. Now normality into volume in liter, or else normality into volume in liter. This is an acid, this is base. This is an acid side and this is base side. If anyone is extra, that means acid is greater or base is greater, number of gram equivalents. Then resultant solution is acidic or basic. If NV of this is an acid is greater than number of gram equivalents of base, then the resultant solution is acidic. because number of gram equivalents of acid is greater, base is less. So then you will, since it is an acidic solution, you have to find out the H plus ion concentration so that you can find the pH of solution. So NaVa, here A means acid and NbVb, B means base by Va plus Vb. Number of gram equivalents of acid minus number of gram equivalents of a base by total volume. Then you will get H plus ion concentration. Then you can find the pH of solution when gram equivalence of acid is greater than gram equivalence of base. The resultant solution is acidic. If gram equivalence of an acid is less and gram equivalence of base is more, then the resultant solution is basic. The resultant solution is basic. Then you can find OH minus ion concentration, that is equal to NbVb minus NaVa by Va plus Vb. This is to find out OH minus ion concentration when gram equivalence of base is greater than the gram equivalence of acid. Next one. Now, what is the relationship between molarity and normality? So, normality is equal to n factor into molarity. Now, what is this n factor? So, n factor is equal to, for acid, it is basicity. For acid, it is basicity. That means number of H plus ion replaced. Number of H plus replaced. Number of H plus ions replaced. And for a base, it is acidity. Acidity, that is number of OH minus ions released. Number of OH minus ions released by a base. Released by a base. And for elements, the n factor is equal to valency. Valency. And for a salt, total positive charge. Total positive charge. And for oxidizing agent, that is number of electrons gained. Number of electrons gained per mole. Number of electrons gained per mole. Number of electrons gained per mole. Next, reducing agent. Reducing agent, that is equal to number of electrons lost per mole. Number of electrons lost per mole. So we'll stop here and remaining. Okay, wait. Okay, last two more formulas we'll discuss here. That is the relationship between molarity and molality. Molarity and molality. So molality is equal to molarity into 1000 by 1000 into density minus molarity into gram molecular weight of solute. And relationship between molality and mole fraction of solute. Mole fraction of, here I am considering as a B as a solute. Then mole fraction of solute is equal to molality by molality plus 1000 by gram molecular weight of solvent. So remember these formulas, because in the NEET most of the times 90 to 99% they will give direct formula based questions only. So mole fraction of solute is equal to molality by molality plus 1000 by gram molecular weight of solvent. If it is water, then you take 18, 55.5, 1000 by 55. 1000 by 18, 55.55. Right? So remaining things we'll discuss in the next class. Thank you.